Today we're going to focus a lot on properties and applying different properties. All of these properties are properties that I think you've done at some point in time, probably haven't been talked about or done for a while. Even though these are things that we use all the time, we don't always say, oh, hey, I'm using the commutative property of addition there. You do it a lot of times like when you're solving an equation or doing some type of simplifying or evaluating. We don't always necessarily identify the property, but these properties tell us why and how we can do the different things that we do. First one we're going to start with is the identity property. And some of these work for both addition and multiplication. They don't work for subtraction or division. Okay, so they don't work for all operations, and we'll talk about why that is here in just a second. Okay, so if we break down the word identity or talk about what it means, if someone or something has an identity, that kind of makes them who they are, right? If you know somebody and you kind of know them really well, like maybe it's the sport that they play. If I talked about a person in the school and you'd be like, hey, that guy plays football. Well, that's kind of part of their identity, right? Because that, or maybe that person's in the band or whatever it might be. It's part of their identity. It's part of who they are, right? When we talk about numbers, then the addition property, the additive identity property, however you want to call it, means if I have a number like 5, what do I have to do to 5 to get back to 5? What do I have to add to 5? Just be 0, right? And so if I said any number plus 0 equals that number, that keeps its identity. A is what we're looking at. In order to keep its identity, we add it to 0. It doesn't change it. It stays the same. And I use the variable here because that variable, kind of like we talked about on Friday, represents any number. Okay? You could put an example in here of, let's say, 6, but it would work for any number. I could say 1 million plus 0, and I would still get 1 million back. It doesn't matter what the number is. Okay, what about multiplication? What do I have to multiply a number by to get back to that same number? 1, right? So if I said A times 1, that gets me back to A. If I use an example with numbers, 6 times 1 gets me back to 6. Okay, so that's what we call the identity property. If we have some number or expression, what do I have to do to get back to that expression or keep it the same, keep its identity? Okay, the next one. Is the commutative property. Okay, commutative property tells me that you have two numbers that are being added together, okay? If I have, let's do m plus n. If I break down the word commutative, the word that you might have probably heard of before is commute. Like for instance, I live in Hutch, but I work in Buhler, so I commute from Hutch to Buhler every day for work, okay? And so commute means to go back and forth. Every day I go back and forth from Hutch to Buhler when I go to work and back. The distance is the same, everything's the same. I might even take the same route. Everything's going to be the same. And so if we switch the order, if I went from Hutch to Buhler and then I went from Buhler to Hutch, it's still the same thing, right? Same thing here. M plus n equals n plus n. You can put numbers in there. So an example would be 4 plus 5 equals 5 plus 4. When I add 4 plus 5, I get 9. If I flip it around and do 5 plus 4, still 9. Okay? Order doesn't change my answer. Okay? I can't do that for subtraction, because if I did 5 minus 4, that would give me 1. And if I did 4 minus 5, what would that give me? Negative 1. Okay? So it doesn't give me the same answer. So that's why we don't have a commutative property of like subtraction. Division is the same way. If I take 8 divided by 4, I get 2. But 4 divided by 8 would make a half, or 0.5. And it's not the same answer. Okay? So subtraction and division are eliminated or out of the mix here. So only addition and multiplication can be looked at. Okay, multiplication is essentially the same property. C times D equals D times C. You can put whatever number you want into that. 2 times 7 equals 7 times 2. It does not matter the order that I multiply those two numbers together. I get the same answer. We call that the commutative property. So all that happens in the commutative property is two things just flip-flop or trade places. But I still get the same result, same solution. Okay, the third property. Is what we call the associative property. Okay, and what you will do here, because there's two different properties for each one of these, if I said commutative property, I couldn't just say commutative property. I would have to say the commutative property of addition, or the commutative property of multiplication. So all it's telling me is what sign, what operation is between those two variables or numbers. All right, so the associative property we're changing what is associated with one another. Okay? In this case, we're doing B plus C first, and we're adding A to it, because A is on the outside of the parentheses. But if I change what's being associated with one another, and I do A plus B first, and then add C, we're changing where the parentheses are at. We're changing what we're grouping together, essentially. We did not flip-flop any numbers or any expressions. A, B, and C are still in the same order, right? Up here, in order for it to be commutative, you'd have to flip the A and the B, or have to flip the B and the C. Here, A, B, and C are still in the same order. We're just changing the grouping. And so to show you kind of how this would work, 2 plus 3 plus 4 equals 2 plus 3 plus 4. Hey, if we did evaluate this, if I did the left-hand side, I would do the parentheses first, right? 3 plus 4 is 7. 7 plus 2 would be 9. Over here, 2 plus 3 is 5. 5 plus 4 is 9. So we got there a little bit different way, but we still got 9, right? We still got the same result. So because they both sides equal 9, we know they are indeed equal to one another. So that is what we call the associative property. Okay, the only difference between the multiplication and addition property here, once again, is if I did m times n times p equals m times n times p. The only difference is we have multiplication signs in there. Okay? And I could put whatever numbers I want to in place of m, n, and p. I could do like 2 times 5 times 7 equals 2 times 5 times 7. Over here, 2 times 5 is 10. 10 times 7 is 70. Over here, 7 times 5 is 35. 35 times 2 is still 70. Okay? Both sides. And we did a little bit different order, right? But we still get 70 as our answer. Okay, so those are those are the ones that have both. The identity, the commutative, and the associative have both addition and multiplication. I'm going to show you some other properties here that only work for one of the operations. Okay, or in the name, it's talking about add or multiply. So the first one we're going to look at here is the additive inverse. Okay, if I have a number up here, we said 0 is the identity, right? 0 is the additive identity. What do I have to add to a number to make 0? So let's look at an example. Let's say I have a number like 9. What do I have to add to 9 to end up as 0? Negative, right? It's opposite, okay? In order to get right in the middle at 0, I have to add its opposite. So the key word that we're looking here is that, the opposite. Opposite means it changes its sign. Anytime you add the opposite to a number, you always end up at 0, okay? So we call that the additive inverse. Those two are additive inverses of one another. If I started with a -3, if I add a +3 to it, I finish out as 0 because they offset one another. This word is kind of a mouthful, but we call it the multiplicative inverse. So multiplicative, obviously that means multiplication. And once again, we see an inverse. Okay, now because it's multiplication though, once again, let's start with F, or letter, okay, whatever letter you want to use. Okay, and we want to end up at the identity, okay? 0 is what we call the identity for multiplication. 1 is what we call the identity. Because remember up above, if we multiplied any number times 1, we always got back to that number, right? So now we're kind of looking at it a little bit differently. We're saying, okay, here's a number that I'm starting with. What do I have to multiply by that number to end up at 1? So let's look at it with, I think it makes more sense with numbers. And I'm going to say 2/3. I'm going to do a fraction. You might say, why'd you use a fraction? Because I think it makes more sense. Any idea what we would have to multiply 2/3 by to get back? Okay, would doing a negative make sense here? No. Because if I multiplied a positive times a negative, it would give me a negative, right? Okay. Yeah, it's 3/2. And what's the word we use for 3/2? 3/2. Reciprocal. You got it. Good. Okay. So if we're trying to figure out what goes in this box here, it'd be 3/2. That number is what we call its reciprocal. We just take the number and we flip it over. And that's why I started with a fraction here, okay? So if I take a number times its reciprocal, and here's why, guys, because if I take 2 times 3 on top, I get 6. 3 times 2 on bottom is 6. 6/6 is 1, and it makes 1, okay? The two are going to basically knock each other out. So over here, if it was a variable, I would say 1/f is its reciprocal. Okay, so if I had a number like, let's say 3, what would be the reciprocal of 3? 1/3, right? Because we know 3 is assumed to be 3/1. We don't always write it as 3/1, but we know it's assumed to be 3/1. We can always put a 1 underneath it. You do that a lot of times if you do like slope. You might remember from like Algebra 1, Algebra 2. in order to do like rise over run, a lot of times we might write it as like 3 over 1. So the reciprocal of 3 over 1 would be 1 over 3. And that is our reciprocal, okay? So that's what we call the multiplicative inverse. We want to get back to the identity, and we have to multiply the reciprocal to do that. Okay, and so it's kind of, I separated these two out. We do have an additive inverse and a multiplicative inverse, so it's still kind of addition and multiplication, but they're two completely different things, so I like to separate them. I don't like to do like we did at the top, because it looks different. One of them uses the opposite, one of them uses the reciprocal. So it's not the same property. Okay, the multiplication property of 0. This one's pretty straightforward. Okay, if I take any number times 0, what do I get? 0. Okay. And it's a property. A property is essentially a rule. This works for all numbers. So that is a rule. No matter what number I have, if I multiply it by 0, I always get 0. So we call that the multiplication property of 0. Okay, the reason we have a property for that is because it's different with addition, right? Addition, when we added it to 0, we got the same thing back. This is multiplication, so it's a little bit different property because of the multiplication by 0. Okay, the last property is what we call the distributive property. The distributive property, this is one that I know we've used a lot, okay? We do this a lot in Algebra 1, Geometry, Algebra 2, to solve a lot of times like a missing equation or a missing value or something like that. And when we see the distributive property, there is no distributive property of addition or multiplication because it's going to look something like this. A times B plus C. And what we're going to do is we're going to take whatever's on the outside and we're going to distribute it to both parts. Okay? Now, in this case, I have variables in all the situations. That's not typically how we will see it or how you have seen it in most cases. But here we have a variable in all 3 locations. So I'm going to take A times B plus A times C. A gets multiplied by both parts on the inside. The plus sign in between stays in between. Okay, to show you why the distributive let's say we simplify the left-hand side here, okay? First thing we're going to do is we're going to do order of operations. So 5 plus 6 is 11. 11 times 4 would be 44, right? Left-hand side becomes 44. If I simplify the right-hand side, 4 times 5 would be 20. 4 times 6 would be 24. 20 plus 24 would be 44, which is the same thing we had over here. Both sides are still the same, but we got there once again a little differently, right? It was not the same process. We did a little bit different math to get there, but both sides are equal, no matter which way that we do it. The way that we're going to see this and use this probably the most, and this is where you've probably seen this the most often, is I have a number on the outside. I'm going to take that number and I'm going to distribute it to both parts. So I'm going to take 2 times y. And then I'm going to take 2 times 8. Okay, and this is a little bit different because I can't combine these two things together. This one has a y, this one doesn't. Those are not the same thing. So I just leave it as 2y minus 16. Okay? So there's 3 different variations. This last one's probably the one that we're most familiar with. We could have all numbers in there just to kind of see and show you how it all works out. You could have all variables. And so they're all doing the distributive property, but we're just applying it a little bit differently to get there. Okay. Some things that we will do with these properties. You could do it both ways, right? I'm going to give you some examples. I'm just going to put an example up here, and we're going to try to identify what property are we using, okay? What do you think? Commutative of addition. Yep. Because there's 2 of them, and most of the time it should be pretty easy, and here would be the way that I would do it. I am okay with abbreviations, okay? Commutative, we can abbreviate commutative to just COMM if you want, and then I just put addition in parentheses, commutative of addition. Commutative's the property, addition is which type. This one's a little tricky. Kind of throwing a curveball at you here already, right? What do you guys think? Do what? Commutative of multiplication. And the reason why it's a curveball is I'll show you another way. This one, we have to go based off of what is written out, okay? And what's written out is 8 times 0 equals 0 times 8. All they did was take the 0 and the 8 and flip-flop them, right? We have to go based off of the way it's written. If I took that same problem and if I said 8 times 0 equals 0, now this one would be the multiplication property of 0. Because when I multiply by 0, I get 0, okay? Over here, we did not flip-flop the 8 and the 0. So that's the difference between the two. Very, very similar information that's going on here, but a little bit different way of recognizing it, of what's going on. Okay, here's another one. And we'll see this from time to time, and I think they do this to kind of throw you off maybe a little bit. The question you must ask yourself is, what changed or what's different, okay? When people see parentheses, immediately they think associative or distributive property, okay? And in most of the case, that would be correct. But just because you see parentheses doesn't mean automatically it's associative or distributive property. What happened here? What changed? What's different? The 3 and the 2 flip-flopped, right? And so the 4 did not change. We do have parentheses, but we're just trying to identify what's different from left to the right. And in this case, the 2 and the 3 had traded places. And so this is still the commutative property of addition. Okay. And we know it's addition because there's a plus sign in between the two things that flip-flopped. Okay, even if I would do this, there are times where I might put a multiplication sign out here. That multiplication sign doesn't really have anything to do with what we're doing. Okay, these are the 2 numbers that are changing places. The sign between them is addition, so we don't even care about the multiplication sign that's out in front. Okay, so there are times where maybe you have both operations and the same problem. Once again, it doesn't change anything. We're also not taking the 4 and distributing it here. Okay. We're just changing the 2 and the 3 around. Okay, so some of them can be a little bit tricky, but once again, if you ask yourself that question of what's happening or what's changing, then we're okay. All right, one of the last things that we're going to do here, a little bit shorter than what we did on Friday. you're going to have some problems today where you're doing some operations, okay? And I'm not going to give you a ton of examples of these because most of these are pretty straightforward to do, and I'm okay with you using your calculator. It's just a real quick evaluate problem. In fact, that's what the directions will say, is it'll give me a problem, and it'll just say evaluate. But I want to kind of remember some of the rules here, okay? If I was going to add fractions, I need to have a common denominator. But if I'm multiplying fractions, I don't need to worry about a common denominator, okay? So when I multiply fractions, it's really pretty easy. All we have to do here is multiply straight across. Multiply the tops together, multiply the bottoms together. If it would reduce, I would reduce it. At this point, it does not reduce. 2 over 15 is our answer. That's all we got to do. Okay? So if we're multiplying fractions, just multiply straight across. If we were adding fractions, a little bit different. Okay? Because they have the same denominator, they both have a denominator of 4, I'm going to keep that denominator the same. It's going to stay 4. And then 3 plus 5 would be 8. But 8 over 4 can reduce, right? 8 over 4 is really 2. And so if we can simplify it, we simplify it. Okay. What if I would have had an answer of like 7 over 4? Is it okay to leave an answer with the number on top bigger than the number on bottom? Yeah. Okay. We would call this an improper fraction. I know sometimes, like way back, like maybe elementary, middle school, when you start doing fractions, sometimes your teacher might have said, well, we don't want to leave it as an improper fraction. Okay. I don't have an issue with an improper fraction. In fact, it's probably the easiest way to leave it. You could do 7/4. You could do 1 3/4. Or you could do 1.75. Okay, I probably prefer this one out of all three of them because you don't have to rewrite it. And what happens if like we have a repeating decimal or a longer decimal? We don't have to worry about like where do we round or do we round or any of that kind of stuff. So usually the fraction is the best way to leave it as, and just know that improper fractions are okay. Okay, there's no worries about that. All right, last one, and this one's a little bit different. One third divided by 2/5. This one's a little bit tricky. When we divide by a fraction, there's a rule that I'm guessing most of you have heard this rule before. What do we have to do? Keep, change, flip. Yep. Whenever we divide by a fraction, the rule is keep, change, flip. Anybody never heard that before? You guys have probably heard that before, right? Keep, change, flip. Okay, here's what it means. Keep means we're going to keep the first fraction. 1/3, nothing happens to it. It stays 1/3. Change means we're going to change the division sign to a multiplication sign. Okay, here's another important thing that I think it's really important for you guys to start doing. Don't use x for multiplication, ever, from here on out, because we're in algebra, right? And if I do an x for multiplication, sometimes I'm going to think that that is a variable instead of a multiplication sign, or vice versa, right? So always use the dot for multiplication. Don't use the x for multiplication. I know that's something that you did way back when, probably in middle school, maybe in elementary school. That can be really confusing. If I see an x in there, I'm trying to understand what it means. So just something to try to get out of the habit of using. If you still use an x for multiplication, you got to try to get out of that habit. And then flip means 5/2. We're going to flip. We're going to take the reciprocal of that second fraction, and we're going to make it to be 5/2. Now we're going to multiply straight across. 1 times 5 is 5. 3 times 2 is 6. 5/6 does not reduce, so we got it. Okay, now, can I put this into my calculator? I know most of your calculators have a fraction button. I can put it into my calculator, but sometimes it's good to understand how and why. Where did that come from? Why did we get there? So anytime you divide by a fraction, you're doing what we call keep, change, flip. All right, assignment for today. Okay, so what does by 4 mean? There's 98 questions, right? Well, I'm not going to make you do like odds or evens or anything like that. So we're going to go by 4s. So we're going to start with 10. And then we're just going to add 4. Okay, so then the next one would be 14. So you got to do a little bit of math when you're doing your assignment, right? And then we're going to do 18. And we're going to keep going. And then as long as I counted right, then we should stop at 98 would be the last problem that we do. Okay. So it sounds like a lot, and it's probably more than what I typically will assign, but what I will tell you today is most of these problems, there's not a whole lot of work to be done. Okay. The first set of problems, you're identifying property. We're doing inverses. And then it's just a lot of evaluation. So there's really not a lot of work on these problems today. So it's probably a little bit more problems than what I typically assign. I think there's around 20 questions today, but none of them take a big amount of time. There's not a lot of solving, okay? So just know that it looks like a lot of problems in it, and it kind of is, but it won't always be this long.